हाय एवरीवन। तो आज हम सीखने वाले हैं आयोनिक इक्विलिब्रियम। इट इज द concept which is related to the ions which are dissociating into the aqueous solution or any other solutions, right? So before starting with the chapter, let me introduce you one thing that there are many scientists who have done their research, the great research on this topic, right? Correct? Yes. So the first scientist who has done the research on all these things, that is based on the electrochemistry. What do you mean by electrochemistry? The study which is related to the current electricity, right? So electricity is the flow of electrons, or the flow of ions. Electricity is produced by flow of electrons or flow of ions. So flow of electrons, the concept which is related to the physics, but flow of ions is the concept which is related to chemistry. And in that, how the equilibrium is attached, how the equilibrium is attained in a chemical species or in a solution, that we are going to know. Equilibrium, do you know there are two types of equilibrium, physical and chemical. So which is this type?
Ionic.
Chemical equilibrium,
Yes.
right? So it is one of the type of chemical equilibrium where the substance is getting dissociated means breakdown. Understood?
Yes.
So there are many terms which are involved in them. First term is what? Electrolytes. First term is electrolytes. Electrolytes are the substances which can dissociate into its ions. Dissociates into its
Ions.
substances which can dissociate into its respective ions. Correct?
Yes.
And there are the substances which do not dissociate, right? So these substances are known as non-electrolytes. The substances which do not dissociate into its ions. Correct?
Yes.
So the examples of the electrolytes are, there are many examples. So first we will do the classification of the electrolytes. Electrolytes are of two types, first one and second one. The first one is the strong electrolytes and the second one is weak electrolytes. So strong electrolytes are the electrolytes which can dissociate completely. Dissociates completely. And the weak electrolytes are the substances which do not dissociate completely. They dissociate but partially. Partially they dissociate. Easy?
Yes.
So if I give you the examples of the substances, can you able to tell me which are the substances which are strong and which are weak? By looking at the formulas you can't, because you don't know what are acids and what are bases, right? So for that we are going to learn about acids, bases, right? Acids and bases. Acids are the substances which produce
H plus
H plus
ions.
but bases are the substances which produce
ions.
Correct. So these are the theories which are given by the one scientist only, right? But there are many types of acids and many types of bases in the nature, right? First example of the acid is what? The well known, that is the HCl, which is the
hydrochloric acid.
hydrochloric acid. Then H2SO4, then HNO3. These are what? Proton donors. These are what? Proton donor acids. Proton donor acid means they produce H plus when they dissociate into ions.
Ions.
Okay, suppose if I take an example, suppose HCl is dissociating into water. Sorry. Okay, it will dissociate completely. Why? Since it is strong electrolyte. Since it is strong electrolyte, it will dissociate and it will form H plus Cl minus. That H plus which is formed, that is getting reacted with, combined with H2O, and it will form H3O plus ion and Cl minus. So this is the symbolic representation of the irreversible reaction.
Yes.
Which reaction?
Irreversible
reaction. So after this, if I do the same reaction for the CH3COOH, since it is an organic acid, it is a weak acid containing the carbons and hydrogens, right?
Yes.
The functional group which is involved over here is the carboxylic acid. What is the name of this compound? Its name is acetic acid. If you see the IUPAC nomenclature, its name will come as 1, 2 carbons, right? So if N, because no double bonds are there in the carbon chain, ethanoic acid, correct? When it will react with the water, since it will form the aqueous solution, right? So what happens in the aqueous solution, that we are going to learn. Understood?
Yes.
And how it is related to electrochemistry, that I am going to learn. Since it is weak electrolyte, weak acid, it will dissociate partially. Means suppose out of 100 molecules it is dissociating, right? Out of 100, it will dissociate partly, means 40 to 60 or 20% it will dissociate. Or 10 or 1% also. Understood? Yeah. So its dissociation will be represented by the reversibility sign. Okay? Since it is partially dissociating, it will dissociate and it will combine also. Yeah. So after dissociation, it will form CH3COO minus ion plus H3O plus ion. Understood?
Yes.
H plus known for proton and H3O known for hydronium ion.
Ion.
Since it is made up of water, containing water, H3O plus, it is hydronium ion. Same thing if you apply for the bases. If you apply for the bases, what will happen? Can you tell me one base? Yeah. First base, if I take the strong base, that is NaOH, the well known sodium hydroxide. Sodium hydroxide, when it dissociates in the water, it will dissociate completely. So forward direction sign, irreversible reaction.
Yes.
It will form Na plus, correct, and OH minus. Na plus and OH minus ions plus water, correct. That water when it reacts with the OH minus ion. Understood?
Yes.
Now, when it reacts with the ions, suppose salt, if we take, when we take an example of salt, the example is the NH4 plus and Cl minus, that is ammonium chloride. Since it is a salt which is made up of the ammonia and hydrogen chloride, the strong acid and a weak base. So its nature will be acidic in nature. So salts are dissociating completely in the water. So in the aqueous condition it will dissociate and it will form NH4 plus ion plus Cl minus ion. Yes?
Yes.
Since all these substances which are solid in nature, they do not conduct electricity. They don't conduct
Electricity.
electricity, but in the aqueous form or in the liquid form they can conduct electricity. Right? That's why salts are also used in the electrical fire as a fire extinguisher, right? After this, the concept which is coming, that is the Arrhenius concept, Arrhenius theory, Arrhenius theory of acids and bases. What does it tell you? It is telling you that the acids are the substances which can dissociate, which can produce H plus ions in its aqueous solution. In its
Aqueous solution.
So aqueous solution is the condition. Which solution?
Aqueous solution.
Solution. They will produce H plus ions. Okay. If they are producing H plus ions, they are known as acids. And in the aqueous condition only, if the substance is producing OH minus ions, they are known as bases. Understood?
Yes.
So, after this theory, there are many acids and bases which can dissociate H plus ions irrespective of the water. Since water is one of the solvent, right? Which is having high dielectric constant. Right? Water does not conduct electricity. Which water? Pure water. But if any ions are dissociating in that, they will conduct electricity. Abhi. Since the chapter which is related to the ionic equilibrium, whatever the ions which are producing that are responsible for the properties of the substances, therefore the ions which are dissociating that are related to the colligative properties of the substances. Which properties? Colligative properties. Colligative properties of the substances. Since colligative properties are related to the amount of substance which is present in the material, right? Amount of the ions or amount of the matter which is present, whatever the properties are there, if they are fluctuating or we can say they are deviating from their nature, then that properties are known as colligative properties. There are 4 colligative properties. Okay. First colligative property is what? That is elevation in boiling point. Elevation in boiling point. Second one, depression in freezing point. Depression in freezing point. Third one is the osmotic pressure. And the fourth one is the RMVP, that is relative lowering of vapor pressure. These are the properties which are related to amount of substances present. Means suppose this one particular salt is there, right? One substance, one mole, but after dissociating it is forming 2 ions. 1 plus 1, right? 1 plus 1. Now the property is getting doubled in the variation, right? Understood? Now, the third point which is there in this ionic equilibrium, that is the next concept of the acid bases. Right? Before going to that, we are going to learn about alpha. About alpha. Alpha is what? Degree of dissociation. Degree of
Dissociation.
Dissociation. What do you mean by this? Suppose you have it is generally related to the mathematics. Okay, suppose there are 1, 2, 3, 4, 5, 6, 7 parts. 7 parts are there of this block. One block you have taken, out of that 7 parts you have to do. So what is degree of dissociation? We are going to learn from this. Okay. Suppose of this block, this much part is getting eliminated, and this much part is also getting eliminated. How much part is getting eliminated over there?
Two parts.
2 parts of how many parts? 7 parts.
7.
Means what? Fraction of the part is getting eliminated.
Yes.
So that is only the degree of dissociation. Suppose in a particular solution, I am telling. Okay, solution is made up of 2 things: solid plus solvent. Here our solute is what? Acids, bases, or salts. Okay, salts may be neutral, may be acidic, may be basic, may be acid. Okay,
Yes.
depending on the nature of the substance. Right? So, what is alpha over there? Number of particles dissociated are getting ionized, ionized divided by total number of ions, right? Total number of particles are ions. So, if I say you wanted to do the percentage of alpha, how you will calculate the percent alpha? Just by multiplying this number with the alpha, right? 100 with the alpha. After this, if you want to do something right, this much you understood, right? After this, you have one concept that is alpha with respect to acids. Okay, for strong acids, suppose acids are also 2 types, right? Strong acids and weak acids. So, if I continue this discussion with the electrolytes, what can you tell? Electrolytes. Degree of dissociation will be 1 for the strong electrolytes, since they are doing their complete dissociation over time. Means what? 100% if they are getting dissociated, right? So alpha will become 1. Suppose all this part, full of this part is getting eliminated. Your division will become 7 by 7, that is 1. Correct?
Yes.
That's why for the partially dissociation, okay, from electrolytes, and for the partly dissociation, alpha will be lesser than 1. Always it will be lesser than 1 for weak electrolytes. Correct? Understood? Suppose if we take one reaction, that is suppose strong electrolyte HCl का ही देते हैं. HCl in the aqueous condition it will dissociate into complete dissociation, right? So reversibility sign will not come. It will come as H plus Cl minus, which are also in aqueous condition. Correct? After this dissociation, suppose initially there are number of moles, right? Suppose 1 moles are there. Here the number of moles which are dissociated are 0. Initial condition P 0. But after some time, suppose T, what will happen? The dissociation will happen and the 0 molecules of the HCl will be there, and whatever the dissociated atoms will be there, that are alpha. and here the degree of dissociation will become 1. Understood? So 1 ion of each will form. But this case is not followed by the weak acids and weak bases. Right? Suppose this is aqueous. After dissociation it will form CH3CO minus plus H plus. Correct? Initially at T0 they are 1, they are 0, 0, but at Tt they are becoming, they are having some value. Suppose alpha is getting dissociated. From this how much is getting dissociated? 1 minus alpha. Since its value is not 1, we are not getting 0 over here. Okay? Understood? For concentration terms, if we derive this, what we will get? Concentration term T at T will become C into 1 minus alpha. Correct? And this will become C alpha. Correct?
Yes.
Okay, if you want to find out the equilibrium constant of a reaction, since HCl is a strong electrolyte, it is dissociating completely, therefore it will not undergoing any kind of equilibrium. Equilibrium is applied for reversible things. So this reversible reaction, which is the dissociation reaction, for that we are writing K, that is the equilibrium constant. And for the equilibrium constant, according to the law of mass action, we know what? Product concentration upon reactant concentrations raised to their powers of stoichiometric coefficients.
Yes.
Right? So after that, if we write CH3CO minus concentration and H plus ion concentration, divide by CH3COO H. Right? What concentration I will get? C into 1 minus alpha downside. Correct? And COH concentration, COO minus concentration ions will be C alpha, and here also C alpha. It will become as C square alpha square upon C into 1 minus alpha. If we divide both numerator and denominator by C, what we will get? C cut. Right? What we will get? And then is C alpha square upon 1 minus alpha. Understood? For very weak electrolyte conditions, we are taking this alpha as for weak electrolytes only, for very weak electrolytes, or we can say their dissociation is less than 10%. So its alpha will become 0.1, lesser than 0.1. So this alpha is much more lesser than 1 in this condition. So 1 minus that will become what? 1 only?
Yes.
So K will change at C square upon 1, that is C into alpha square. Understood? Yes. Thank you.